Okay, we are in the second section of Chapter 7, Laws of Exponents Dividing Monomials. We're going to divide monomials using the property of exponents, and we're going to simplify expressions containing negative and zero exponents. Okay, so first we're just going to simplify monomials by dividing using the property of exponents. So if we have a to the sixth divided by a to the fourth, that means we have 6a's multiplied and 4a's multiplied. Anything divided by itself is 1, so we really shouldn't say cancel, but it simplifies to a 1. 1 times a, which is a squared. Notice, what's 6 minus 4? 2. So we could have just subtracted rather than writing all out and canceling things out. Now, there's a rule that can be discovered using that example. It's called the quotient of powers rule. Okay, and it's to divide powers with the same base, you subtract the exponents. So to divide two powers with the same base, subtract the exponents. Okay, so for example, if we had a to the m, if we had a to the m over a to the p, that would be equal to the am minus p. You just subtract your exponents, okay? So for example, a down here, you have the same base of 2. So that's the same thing as 2 to the 6 minus 4, which is 2 squared, which is 4. You could have written it out as 2 times 2 times 2 times 2 times 2 times 2, all over 2 times 2 times 2 times 2. And you would have gotten the same answer. Okay. So same thing here. We have the same base. 9 minus 7 is 2, which is 100. So those are easy enough. Let's try a little more difficult with letters. X to the third, x to the first, 3 minus 1 is 2. X to the a over x to the first is x to the a minus 1. That's your answer. X to the a plus b over x to the c would be x to the a plus b minus c. Same thing here. Look at the letters. That's going to be 5 minus 3, 2. 2 minus 1, 1. These aren't the same base, so we just have to divide them like normal. Negative 4 divided by 2 is negative 2. That's it. Here, there's no other b, there's no other a. 2 minus 2 is 0. But also, c squared divided by c squared is just 1. So we can say any exponent raised to a 0 is 1. Here's another example. What if we had a to the 5th divided by a to the 5th? Well, everything divided by itself is 1. So a to the 5 minus 5, which is a to the 0, is just 1. Anything to the 0 power is 1, unless this is 0. Anything to the 0 power is 1. All right, let's try this one. So this is from yesterday. Anything that has a power raised to another power, you multiply. So this is negative 2 to the third, y to the 5 times 3, which is 15, 2 to the x y third. That wasn't in parentheses, so that's why that doesn't get raised. This is going to be a negative 2 times a negative 2. 4 times a negative 2 is a negative 8. Negative 8 divided by 2 is negative 4. Y15, Y3 gives you Y12. That's it. Okay, so we simplified dividing with exponents by subtracting those exponents. We also talked about when we have a power raised to zero, I'm sorry, we have an amount raised to the zero power is always going to be 1. One thing we didn't discuss was negative exponents. So for instance, what if this wasn't 2 to the 6 over 2 to the 4th? What if it was 2 to the 4th over 2 to the 6th? Well, if we use our subtraction method, 4 minus 6, that would give us a negative 2. Well, what would it look like if we simplified it the long way? Everything would be 1. It'd be 1 over 2 squared. So we can conclude if you're negative, you need to be moved. If you're negative, you need to be moved. What if it was flip-flopped this way? Seven of them would simplify to 1, and it'd be 1 over 10 squared. 7 minus 9 is negative 2. It needs to be moved if it's negative. So we can conclude a negative exponent needs to be moved. So for any non-zero number where it is raised to a negative exponent, it is the reciprocal of the positive one. So they're reciprocals of each other. Okay, and that's it. So if you are in my spring 2020 virtual 180 class, you're going to be doing Delta Math. If this is for a different class, you might have bookwork, you might have a worksheet. So just make sure that you know which homework goes with these notes.